Hello, welcome to my channel Qubit Educational Services. In this video we are going to see how to solve question number 3 from NEST 2020 second shift. This question is based on matrices and the properties of the adjoint. Let A be a 3x3 non-singular matrix with real entries. Suppose the determinant of A is K. Then adjoint of A is equal to, and we have got 4 options. Okay, now we know very well how to find adjoint of any matrix, but we may not be knowing how to find its adjoint. Okay, the proof involves only one critical step. I'll tell you what that step is. And secondly, we are going to generalize this result for any square matrix, non-singular matrix of order n. Okay, and if we substitute n equal to 3, then we will get the solution to this particular problem. Okay, now the formula is that if you find adjoint of adjoint, it is given by determinant of the original matrix raised to n minus 2 times the original matrix. Okay, we will now prove this. We start with our very well known relation that if A is non-singular, then the inverse exists and is unique, and A into A inverse is equal to the identity matrix of appropriate order. Okay, now by the adjoint method, A inverse is given by 1 over determinant of A into adjoint A. So we can shift the scalar, which is determinant of A, to the other side, and hence we will get the relation A into adjoint of A equal to determinant of A into I. Okay, and because adjoint of any matrix is unique, we can have A into adjoint of A equal to adjoint of A into A. Okay, we know that A inverse into A is also equal to I. So we can use the matrix commutative property, which is otherwise not true, or usually not true, but in this case it is true. Okay, and this is the relation which is going to help us in arriving at our result. Okay, so let us call it alpha. Now, if adjoint of any matrix multiplied by the original matrix is equal to the determinant into the identity matrix, we can apply this on adjoint of A, which means if I call adjoint of A as matrix B, then what relation can I write? I can write adjoint of B into B equal to determinant of B into I, and that's exactly what I have done in the next step. So in the next step, I have replaced A by adjoint of A. Okay, so we have got adjoint of A into adjoint of A equal to determinant of adjoint of A into I. You can pause the video and reflect on this step, because the next step is going to be the crucial one. Okay, in the next step, what we are going to do is we are going to multiply both, or post multiply both sides by the matrix A. Okay, and you can see that here on the LHS we have post multiplied by A, and we have to do the same thing on the right hand side. Okay, now by the associative property of matrix multiplication, we can say that adjoint of A into A, we can club them together and write it as determinant of A into I, and this is from alpha. Okay, and I into A is I itself. Yes. Now see, the power of this particular step is that it has adjoint of A on one side and the identity matrix on the same side. Okay, so we have virtually got the answer. We now need to shift determinant of A to the other side. Because it is a scalar, we can do that. Alright. Yes. So in the next step, we divide both sides by the scalar determinant of A. So adjoint of A is equal to determinant of A divided by determinant of A times A. Okay, now there is one small step that's remaining, in which we will be finding the expression for adjoint A's determinant. Okay, many of you might already be knowing this, but let me just tell you in case you don't. Okay, now here again we go back to our equation alpha, adjoint of A into A equal to determinant of A into I, and we recall this property that determinant of A into B is equal to determinant of A into determinant of B if A and B are square matrices. So using this property, we can say that determinant of adjoint of A into determinant of A is equal to the determinant of the right hand side, And if we have identity matrix of order n, then every diagonal element of determinant of A into IN will be determinant of A. Okay, so effectively the determinant is going to be determinant of A raised to n. Alright, so we want this particular determinant, which will be determinant of A raised to n minus 1. Okay, so we now have everything that we need. We will substitute this in the numerator here. So the final result or the eventual result is adjoint of A is equal to determinant of A raised to n minus 2 times A. Now the last thing that is remaining as far as this question is concerned is letting n to be 3, because A is a 3 by 3 matrix in the problem. So if we let n to be 3, then it is going to be determinant of A raised to 1 or determinant of A itself, which is k in the problem. So it is going to be k times A. And do we have that option? Yes, that is option 3. Alright, so we have successfully solved question 3 from this paper. For solutions to the remaining questions of this paper as well as of other NEST papers, please check the video description. All the best and thank you.